Imagine a system where multiple AI agents collaborate on research and writing tasks directly on your own laptop. Today, we are building a private, multi-agent environment where specialized models work together to solve problems. We will use two open-source tools to build this. Ollama provides the local interface to run high-performance models, while CrewAI serves as the orchestration layer that organizes those models into a collaborative team. To follow along, you will need Python version 3.7 or newer, a code editor like VS Code, and basic access to your computer's terminal. By running this system locally, you eliminate recurring cloud API fees. Everything stays on your own hardware, ensuring your prompts and data remain private. Step 1 is installing Ollama. Go to the official website, download the installer for your specific operating system, and follow the standard setup prompts. Open your terminal and type Ollama run Llama 3. Large models require significant memory. If your machine struggles to respond, you can stop the process and try a smaller model like Mistral or Phi 3. This command pulls several gigabytes of model weights to your machine. The duration of this step depends entirely on your local internet connection. Once the download completes, the terminal will wait for your input. Type a simple prompt like hello and press enter. When the model generates a response, your local installation is verified. Your local model backend is now active and ready to process incoming logic within a secured offline environment. Next, we need the framework that will manage our agents. In your terminal, type Python-version to confirm your environment meets the 3.7+ requirement. Now, execute the command pip install CrewAI to install the orchestration library. To prevent version conflicts with your other projects, it is best to run this command inside a dedicated Python virtual environment. With the framework installed, we can define specific roles and coordinate their execution. The agents are currently dormant, waiting for us to script their behavior. Open VS Code and create a new Python file named myfirstcrew.py. First, we define our agents, a researcher and a writer, and connect them to our local Ollama host. Then we define tasks, assigning a search directive to the researcher and a summary to the writer. Finally, we define the crew, grouping them into a sequential pipeline. This transforms isolated AI queries into a collaborative workflow. The agents automatically pass their findings to one another until the final objective is reached. Save the file, return to your terminal, and run the script by typing python myfirstcrew.py. You see the process start. The terminal streams the researcher's step-by-step reasoning as it gathers data, followed by the writer's process compiling the final response. If the script fails immediately, ensure your local Ollama service is active. You can verify this by running Ollama serve in a separate terminal window. When the process concludes, you will see a finished text document. You have successfully orchestrated two local models to complete a multi-step task with a single command. You have just generated a researched piece of content using a pipeline that runs entirely on your own hardware, without external usage fees. This hierarchy shows how you can scale this logic. By introducing a global planner agent to oversee subtasks, you can build much more complex systems for specialized technical or creative workflows. You can now experiment with the system by swapping out the underlying model in your script. Testing different open-source models will help you find the right balance of speed and reasoning for your specific needs. You now have the foundational skills to orchestrate multiple specialized agents for increasingly complex private workflows.